Deep Dive Tutorial. Identify and connect to data sources in Power BI. Power BI allows you to connect to a wide variety of data sources, such as databases, web services, files, and cloud data. This tutorial will walk you through the steps of identifying and connecting to these sources in detail. 1. Identify data sources. The first step in using Power BI is identifying where your data is stored. Power BI supports numerous types of data sources, such as databases, SQL Server, Oracle, MySQL, PostgreSQL, etc. Web services, OData, REST APIs, and other online services. Files, Excel, CSV, JSON, XML, etc. Cloud data, Azure SQL Database, Azure Data Lake, SharePoint, Google BigQuery, etc. You should choose the data source based on your business needs and the storage location of your data. 2. Connecting to databases. To connect to relational databases such as SQL Server, Oracle, or MySQL, follow these steps. SQL Server Database Example 1. Open Power BI Desktop and select Get Data from the Home ribbon. 2. In the Get Data window, choose Database SQL Server. 3. Enter the server name and database name. You can specify additional parameters, such as direct query or import mode. For direct query, queries are executed in real time against the database. For import, the data is loaded into Power BI. 4. Click OK. 5. If needed, enter your authentication credentials, Windows, database, or organizational account. 6. Once connected, Power BI shows a navigator window where you can select the tables or views you want to load. 7. After selecting the required tables, click Load or Transform Data if you want to use Power Query to transform the data. B. Oracle Database Example 1. Install the Oracle Database client drivers. 2. Get Data Database Oracle Database. 3. Enter the server name and specify any connection settings, for example, port and service name. 4. Enter your credentials. 5. Choose your tables from the navigator and either load or transform the data. Tip: always make sure to optimize queries for large databases by applying filters early in the connection process. 3. Connecting to web services. Power BI can also consume data from web services, especially those providing data via REST APIs or OData feeds. Connecting to an OData feed. 1. Get data other OData feed. 2. Enter the URL of the OData service. 3. Click OK. 4. If the service requires authentication, enter the necessary credentials. 5. In the navigator window, select the tables or endpoints provided by the OData service and load the data. B. Connecting to a REST API. 1. Get data other web. 2. Enter the API URL. 3. If the API requires authentication, pass in your credentials or use API keys. 4. Click OK. 5. Power BI will connect to the API, and you'll see the navigator window for selecting the data available through the API. Tip: use parameters or queries to filter data when working with large APIs. 4. Connecting to files. Files such as Excel, CSV, XML, JSON, etc. can be connected directly to Power BI. Excel file example. 1. Get data file Excel. 2. Navigate to the Excel file on your system. 3. Once selected, Power BI will open the navigator window showing all available sheets and tables in the Excel file. 4. Select the sheets tables you want to work with and click Load. CSV file example. 1. Get data file text CSV. 2. Navigate to your CSV file and select it. 3. Power BI will automatically detect the structure of the CSV. 4. You can transform the data if necessary or click Load to bring it into Power BI. See JSON file example. 1. Get data file JSON. 2. Select the JSON file. 3. Power BI will convert the JSON structure into tables. 4. Choose which sections to load or transform the data as needed. 5. Connecting to cloud. Here's a deep dive into identifying and connecting to data sources, as well as cleaning and transforming data in Power BI. Part 1. Identify and connect to data sources. Power BI allows you to connect to a wide range of data sources, including databases, web services, files, and cloud services. Here's how to do it. 1.1. Connecting to databases. Supported database types: SQL Server, Oracle, MySQL, PostgreSQL, SAP HANA, IBM DB2, Azure SQL Database, and many more. Steps to connect to a database. 1. Launch Power BI Desktop. 2. Click on Home tab, select Get Data. 3. Choose Database from the list of available connectors. Then select your database type, for example, SQL Server, Oracle, etc. 4. Enter the server name and database name. 5. Choose the data connectivity mode: import or direct query. Import imports data into Power BI for modeling and visualization. Direct query queries the database live. 6. Provide authentication credentials: Windows, database, or oath. 7. Click OK to establish the connection. Example: connecting to a SQL Server database. Get data SQL Server, enter server name and optional database name, choose import direct query, provide credentials, select tables views to load. 1.2. Connecting to web services. Popular web services: REST APIs, JSON, XML, OData feeds, Azure services. Steps to connect to web services. 1. Go to Home tab, select Get Data Web. 2. Enter the URL of the web service or API endpoint. 3. If authentication is required, provide the necessary API key, oath, or other credentials. 4. Power BI will attempt to fetch data from the service, displaying it in Power Query for further transformation. 5. Select the data fields you need and load them into Power BI. 1.3. Connecting to files: Excel, CSV, text, XML. Supported file formats: Excel, CSV, XML, JSON, PDF. Steps to connect to files. 1. Go to the Home tab, select Get Data. 2. Choose File and select the type of file, for example, Excel, CSV, etc. 3. Browse to the file location on your local machine or OneDrive. 4. Once you select the file, Power BI will display a preview of the file's contents. Click Load to bring the data into Power BI, or choose Transform to open Power Query for data cleaning. Example: connecting to an Excel file. Get Data Excel, select File Preview, Data Load, or Transform. 1.4. Connecting to cloud data. Popular cloud data sources: Azure SQL Database, Azure Data Lake, Google BigQuery, Amazon Redshift, Microsoft Dynamics 365. Steps to connect to cloud data. 1. Go to the Home tab, select Get Data, choose Azure or other cloud source. 2. For example, select Azure SQL Database or Azure Data Lake. 3. Provide the server name and database name and authentication details. 4. Choose whether to import the data or use direct query. 5. Power BI will then connect to your cloud data source and allow you to import or query the data. Part 2. Clean and transform data. 2.1. Power Query Editor Overview. After connecting to data sources, Power BI allows you to clean and transform data using Power Query Editor. This tool provides a comprehensive environment for data transformation tasks like removing rows, changing data types, renaming columns, etc. To access Power Query Editor, after connecting to a data source, click on Transform Data. This opens the Power Query Editor, where you can modify the structure and content of your data. 2.2. Common data transformation techniques. 1. Remove columns rows. Removing unnecessary columns. Select the columns you don't need, right-click, and choose Remove Columns. Remove top or bottom rows. Go to Home, reduce rows, remove rows, and choose from options like removing the first or last rows. 2. Filter rows. Filter data by values. Click on the drop-down menu in the column header to filter rows based on specific values or ranges. 3. Change data types. Power BI may not always recognize the correct data types, for example, numbers as text. To change, go to the column header, right-click, and choose Change Type. Select the appropriate data type text, date, decimal, whole number, etc. 4. Split columns. If a column contains multiple pieces of data in a single field, for example, full names, you can split it. Select the column, then go to Transform Split Column. Choose how to split, for example, by delimiter, fixed number of characters. 5. Merge columns. To combine multiple columns into one, select the columns while holding Ctrl, then go to Transform Merge Columns. 6. Replace values. You can replace specific values across a dataset by selecting a column and going to Transform Replace Values. 7. Pivot and unpivot columns. Pivot transforms rows into columns, useful for reshaping data from long to wide format. Unpivot converts columns into rows, often used to make the data more analyzable. Example, changing column type and removing unnecessary rows. After loading data, right-click on the Date column, choose Change Type, and select Date. Select the rows you don't need, right-click, and choose Remove Rows. 2.3. Data profiling. Power Query Editor allows you to profile data to better understand its quality and structure. You can enable these options under View. Column distribution shows how many unique and distinct values are in each column. Column quality displays error, empty, and valid value percentages. Column profile provides detailed statistics for each column, such as min, max, average, etc. 2.4. Apply changes. Once you've cleaned and transformed your data, 1. Click Close and Apply in the Power Query Editor to load the data into Power BI's data model. 2. The transformations will be applied and reflected in your data model for further analysis and reporting. By following these steps, you can easily identify, connect, clean, and transform data from various sources in Power BI. Mastering these techniques will allow you to optimize data for reporting and analytics, which is a key requirement for the PL300 exam. Optimize performance. Deep dive tutorial. Optimizing performance in Power BI. Optimizing performance in Power BI ensures that reports and dashboards run efficiently, especially when working with large datasets or complex models. Performance optimization involves improving the speed and responsiveness of both the data model and visuals. Here's a detailed guide to optimize Power BI performance. 1. Choosing the right data connectivity mode. When connecting to data, Power BI offers two primary data connectivity modes: import and direct query. Each has performance implications, and choosing the right mode is essential. 1.1. Import mode. How it works. In import mode, Power BI loads data into memory from the source. The data is compressed and stored within Power BI. When to use. Ideal for small to medium datasets that can fit into memory. Provides faster performance because the data is stored in memory and queried locally. Performance tip. Only load the data you need by applying filters or query folding if supported. 1.2. Direct query mode. How it works. In direct query mode, Power BI queries the data source directly whenever a visual is rendered. No data is imported into memory. When to use. Ideal for large datasets that cannot fit in memory or when data needs to be accessed in real time. Typically used for live connections to SQL Server, Azure SQL Database, and other enterprise-level sources. Performance tip. Optimize your data source indexing Query performance, since performance depends on the data source's ability to execute queries. 1.3. Dual storage mode. How it works. Power BI allows a hybrid approach where some tables are stored in memory import mode, while others are queried live direct query. When to use. When certain dimensions or fact tables need real-time updates, but others don't. 2. Reduce the size of the data model. 2.1. Remove unnecessary columns and rows. Remove columns. Eliminate any unused or unnecessary columns to reduce model size. Remove rows. Use filtering in Power Query to remove rows you don't need, especially in fact tables. Example: if you only need data for the last 2 years, filter out older records. 2.2. Use data types effectively. Ensure that columns use the most efficient data type. Example: use whole number for integer values instead of decimal. Avoid using text columns for high cardinality fields, many unique values, as these consume more memory. 2.3. Avoid high cardinality columns. High cardinality columns, those with a lot of unique values, like GIDs or transaction IDs, can slow down performance. Solution: if possible, remove these columns from the data model or reduce their granularity. 3. Optimize model calculations using DAX. 3.1. Write efficient DAX expressions. Avoid repeated calculations. Instead of writing the same complex DAX calculation across multiple measures, create a calculated measure and reuse it. Use variables in DAX. Variables improve performance by storing intermediate results, which are reused instead of recalculated. VAR sales amount equals sum sales amount. Return divide sales amount. Total orders. 3.2. Optimize time intelligence calculations. Avoid complex, multi-step DAX time calculations, for example, YTD, MTD, unless necessary. You can use pre-built time intelligence functions like total YTD or dates in period to optimize these operations. 3.3. Use SumX, CountX, and other X functions carefully. These iterator functions perform row-by-row calculations, which can slow down large datasets. Minimize their usage when possible. 4. Optimize query performance. 4.1. Query folding. What it is. Query folding occurs when Power BI pushes transformations back to the data source, allowing them to be executed at the database level SQL, etc. instead of in Power BI. How to use. In Power Query, use functions that support query folding like filtering and aggregating. You can check if a query folds by right-clicking a step in Power Query and choosing View Native Query. Performance tip. Always prefer transformations that fold back to the data source, as this reduces the data processed by Power BI. 4.2. Reduce data granularity. Aggregate your data as much as possible before loading it into Power BI. For instance, instead of loading every transaction, you can aggregate data at the daily or monthly level. 4.3. Use aggregations. Aggregations allow you to pre-aggregate data at the database level for faster query performance in Power BI. Example: store pre-calculated daily or monthly sales figures to avoid recalculating them in Power BI. 5. Use Performance Analyzer. Power BI's Performance Analyzer helps identify bottlenecks by measuring the time taken for each visual, DAX query, and data load. 5.1. Accessing Performance Analyzer. 1. Open Power BI Desktop. 2. Go to the View tab and select Performance Analyzer. 3. Start recording to capture the performance of your report while interacting with visuals. 4. Analyze the results. DAX query time. The time taken to retrieve data using DAX. Visual display time. The time taken to render the visual. Other. Time for non-query tasks, loading, interactivity. 5.2. Optimize based on Performance Analyzer findings. Long DAX query times. Focus on optimizing DAX measures by reducing complexity and using variables. Slow visual display. Simplify visuals, for example. Use fewer data points. Avoid custom visuals that may be resource intensive. 6. Optimize visuals and reports. 6.1. Reduce the number of visuals. Each visual runs its own query, so having too many visuals on a report can slow down performance. Consolidate visuals where possible. Example: instead of separate bar charts for each region, use a single chart with slicers. 6.2. Avoid complex custom visuals. While custom visuals add flexibility, some may not be optimized for performance. Test their impact using the Performance Analyzer and consider using native visuals when possible. 6.3. Pre-filter data for dashboards. Use slicers and filters to load only the necessary data into the visuals, which reduces the data load and improves performance. 7. Use incremental data refresh. Incremental data refresh is crucial when working with large datasets. Instead of refreshing the entire dataset every time, incremental refresh only loads new or changed data. 7.1. Steps to enable incremental refresh. 1. Go to Modeling Manage Parameters. 2. Set up range start and ranking parameters for defining the refresh window. 3. In Power Query, filter your data using these parameters to define the range for the refresh. 4. Publish the report to Power BI service and configure the incremental refresh policy. 8. Other general optimization tips. 8.1. Use star schema for data modeling. A star schema with fact and dimension tables leads to simpler DAX and better performance. Avoid using a single flat table or snowflake schemas unless necessary. 8.2. Avoid nested calculated columns. If possible, calculate columns in Power Query instead of in the DAX model, especially for simple transformations. This improves query performance and reduces model size. 8.3. Use role-level security (RLS) carefully. RLS can slow down performance if applied to large datasets. Ensure that security filters are applied efficiently and avoid unnecessary complexity. By following these strategies, you can significantly optimize the performance of your Power BI reports, ensuring faster load times. Responsive. Deep dive tutorial. Resolve data import errors in Power BI. When importing data into Power BI from various sources, databases, files, APIs, etc., you may encounter errors that prevent you from loading the data successfully. Understanding how to identify and resolve these errors is critical for ensuring data accuracy and smooth performance. 1. Common data import errors. Data import errors generally fall into the following categories: connection errors, problems connecting to a data source; data format errors, issues with the format or structure of the data; data type mismatch, columns or fields having incorrect data types; missing data, gaps in required data nulls, missing values; schema changes, changes in the source schema, new, removed, or renamed columns; data transformation errors, mistakes during the data transformation process in Power Query. 2. Resolving connection errors. 2.1. Incorrect server name or path. If you're connecting to a database or cloud source, for example, SQL Server, Azure SQL Database, and Power BI cannot connect, ensure the following: correct server path. Double-check the server name, database name, or file path you entered. Example: server, database. Windows Net for Azure SQL Database. Network firewall access. Ensure that your machine or network has access to the database or cloud service. Open firewall ports if necessary. Authentication method. Verify that the correct authentication method, Windows Basic Oath, is selected. 2.2. Connectivity issues with cloud services. When connecting to cloud services like Azure, SharePoint, or Google BigQuery, correct credentials. Ensure you are using the correct credentials or API key. Timeout errors. For large datasets, consider using direct query mode rather than import mode, as this allows Power BI to run live queries rather than importing massive amounts of data. How to resolve. 1. Go to Home, Get Data, and recheck the connection details. 2. For databases, verify the server address, authentication type, and database name. 3. For cloud services, ensure your credentials are up to date and valid. 3. Resolving data format errors. Power BI expects certain formats when importing data, especially from files like Excel, CSV, JSON, etc. Errors may occur if the data is not formatted correctly. 3.1. Incorrect column headers or delimiters. For CSV files, ensure the delimiter comma, semicolon, tab, etc. matches what Power BI expects. In Power BI, you can manually specify the delimiter when importing CSV files by selecting Text CSV and choosing the appropriate delimiter in the import window. 3.2. Mismatched data types. Columns containing values in the wrong data type, for example, text in a numeric column, can cause errors during import. In Power Query Editor, you can use the Change Data Type option to correct column types, for example, from text to number. How to resolve. 1. Inspect the source file. Open the CSV Excel file and ensure that all headers are clearly defined and data is consistent. 2. In Power BI, after importing the data, go to Transform Data Power Query Editor. Right, click the column with the issue and choose Change Type to the correct data type. 4. Resolving missing data issues. Missing data nulls or blanks in your data source may cause problems with analysis or visualizations. 4.1. Handle missing data in Power Query Editor. Power BI allows you to handle missing data by removing rows with null values. In Power Query Editor, you can use Remove Empty Rows under the Reduce Rows section. Filling nulls. Use the Replace Values feature to fill missing values with defaults, for example, 0 for numbers, unknown for text fields. 4.2. Replace errors in Power Query. In case certain transformations lead to errors, for example, converting text to numbers, Power Query allows you to replace errors with valid values. Transform tab, replace errors, enter the value you want to replace errors with. How to resolve. 1. In Power Query Editor, filter out or replace missing values using Remove Rows or Replace Values. 2. For critical columns, for example, ideas, remove rows with nulls. For non-critical columns, consider replacing nulls with default values. 5. Resolving schema changes. If your data source schema, for example, column names or table structures, has changed since the initial import, Power BI may throw errors. 5.1. Missing columns. If a column that was previously used in a report is removed or renamed, Power BI will fail to load the data. How to resolve. 1. Refresh the connection. Go to Home, Transform Data Advanced Editor to check the schema structure in Power Query Editor. 2. Adjust queries. Modify your existing queries in Power Query to reflect the new schema. You can remove references to missing columns or rename them as needed. 5.2. Handling renamed columns. When column names change in the data source, Power BI queries using the old names may break. Use the Transform Data tool to rename columns back to the expected names, or adapt the queries to use the new names. 6. Resolving data transformation errors. Errors often occur during transformations in Power Query when the wrong operation is applied or the data structure doesn't support the transformation. 6.1. Transformation steps not applied in correct order. Power BI applies transformations sequentially. If an early step in your query introduces an error, for example, changing a data type before filtering rows, later steps will fail. How to resolve. 1. Review applied steps. In Power Query Editor, check the Applied Steps pane on the right. Ensure the transformations are applied in the correct order. 2. Undo or delete faulty steps. Right-click any faulty step and choose Delete until end or adjust the step. 6.2. Mismatched data during merge or append. When merging or appending queries, the data types between columns must match. If they don't, Power BI will throw an error. How to resolve? 1. Check that the columns being merged have consistent data types. 2. In Power Query Editor, ensure that before the merge operation, you use change data type to ensure uniform data types. 7. Performance optimization related to data import. Sometimes, import errors are related to performance, especially when dealing with large datasets. 7.1. Apply query folding. Query folding. When using direct query or database sources, Power BI can push transformations back to the data source. This ensures the heavy lifting is done by the server, improving performance. Ensure transformations like filtering and aggregations are performed at the source rather than inside Power BI. 7.2. Avoid complex transformations in Power Query. Avoid performing heavy computations or large-scale transformations in Power Query when connecting to databases. Use the data source's query language SQL for SQL Server, etc. to pre-aggregate or pre-filter the data before it's loaded into Power BI. How to resolve? 1. Use Performance Analyzer in Power BI to identify slow-running queries and bottlenecks. 2. Push filtering, aggregations, and joins down to the source database to optimize performance. 8. Check and monitor refresh. If data import errors persist after resolving the above issues, it's critical to monitor the refresh process. 8.1. Scheduled refresh errors. Check Power BI service for scheduled refresh errors. You can review detailed logs that indicate the type of issue, such as connectivity or timeout issues. 8.2. Incremental refresh. For large datasets, consider using incremental refresh to limit the volume of data loaded during each refresh cycle. How to resolve? 1. Go to Settings in Power BI Service and check the dataset refresh history to review any errors. 2. Use incremental refresh in your Power BI model to improve performance and avoid refresh errors. Conclusion. Resolving data import errors in Power BI is critical for ensuring that your reports run smoothly and accurately. By carefully handling connection issues, data format inconsistencies, schema changes, and missing data, you can avoid common errors and build efficient data pipelines for analysis. For performance, ensuring proper transformations and leveraging the source system's capabilities is key. Master these strategies to effectively troubleshoot data import errors for the PL300 exam. Apply transformations, for example, removing columns, renaming columns, changing data types. Deep dive tutorial. Apply transformations, removing columns, renaming columns, changing data types in Power BI. Transforming your data is a critical step in Power BI for preparing it for analysis and visualization. In this tutorial, we will explore how to remove columns, rename columns, and change data types in Power BI using Power Query Editor. 1. Opening Power Query Editor. Before applying transformations, you need to access the Power Query Editor. This is the environment in Power BI where you can perform all data transformation tasks. Steps to open Power Query Editor. 1. Open Power BI Desktop. 2. Go to the Home tab and click Transform Data. This will open the Power Query Editor window. 3. In the Query Editor, you'll see the data preview and the available transformations you can apply. 2. Removing columns. Removing unnecessary columns reduces the size of the data model and simplifies your dataset. Power BI allows you to easily remove columns that are not needed for your analysis. Steps to remove columns. 1. In the Power Query Editor, select the table from the Queries pane on the left that contains the columns you want to remove. 2. Highlight the column S you wish to remove. Hold down Ctrl to select multiple columns. 3. Right-click on the selected columns and choose Remove, or go to the Home tab and select Remove Columns. If you want to remove columns except for the selected ones, choose Remove Other Columns. Example: you have a sales table that contains several unnecessary columns, such as product ID and warehouse location. To remove these, select the columns. Right-click and choose Remove. The columns will no longer appear in the data model after you apply the changes. 3. Renaming columns. Renaming columns improves clarity and consistency in your dataset. This is particularly helpful when your source data contains ambiguous column names or when you want to follow specific naming conventions. Steps to rename columns. 1. In the Power Query Editor, select the table containing the column you want to rename. 2. Right-click the column header and choose Rename. 3. Enter the new name for the column and press Enter. Alternatively, you can go to the Transform tab and click Rename in the ribbon. Example, if a column is named cust_ID, but you want to rename it to customer ID for clarity, you can right-click on cust_ID, select Rename, and type the new name. Bulk renaming. If you have several columns that need renaming, consider using Transform Data Rename columns for efficiency, though this requires individual input for each column rename. 4. Changing data types. Changing data types is one of the most important transformations in Power BI. By assigning the correct data type, for example, text, number, date, you ensure that Power BI interprets the data correctly and performs calculations efficiently. Common data types. Text, for string values. Whole number, for integers. Decimal number, for numbers with decimals. Datetime, for date and time values. Boolean, for true-false values. Steps to change data types. 1. In the Power Query Editor, select the column S you wish to change. 2. Go to the Transform tab and click on Data Type. 3. Choose the correct data type from the drop-down list. Alternatively, right-click the column header, choose Change Type, and select the appropriate data type. Example, suppose you have a column named Order Date that is stored as text. To perform date-based calculations, you need to change this to the date data type. Select the Order Date column. Go to Transform Data Type, select Date. Power BI will convert the column values to valid dates, which you can now use in time-based calculations. 5. Common transformation examples. 5.1. Remove duplicates. Removing duplicate records is essential to ensure that your analysis is based on unique data points. Steps. In the Power Query Editor, select the column or columns where you want to remove duplicates. Go to Home, Remove Rows, Remove Duplicates. 5.2. Fill missing values. If your dataset contains missing null values, you can fill them with default values such as 0 or unknown. Steps. Select the column with missing values. Go to Transform Replace Values or Fill Down to fill missing values from the row above. 5.3. Split columns. Power BI allows you to split a column into multiple columns based on delimiters or fixed widths. Steps. Select the column you want to split. Go to Transform Split Column and choose the appropriate method, for example, by delimiter or by number of characters. 6. Applying and saving transformations. Once you have completed your transformations, removing, renaming, changing data types, you need to apply them and load the data into Power BI. Steps to apply changes. 1. After completing the transformations, click Close and Apply in the Power Query Editor. 2. Power BI will apply the transformations and load the modified data into the data model. By applying these transformations, you ensure your data is clean, accurate, and optimized for analysis. Cleanse data, for example, removing duplicate data, handling null values. Deep Dive Tutorial. Cleanse data, removing duplicate data, handling null values in Power BI. Data cleansing is a critical step in ensuring the quality and accuracy of the data used for analysis in Power BI. Common data cleansing tasks include removing duplicate data, handling null or missing values, and standardizing formats. In this tutorial, we will explore how to perform these cleansing operations using Power Query Editor in Power BI. 1. Opening Power Query Editor. Before performing any cleansing operations, you need to access Power Query Editor, which provides tools for transforming and cleansing data. Steps to open Power Query Editor. 1. Open Power BI Desktop. 2. Go to the Home tab and click on Transform Data. 3. This opens the Power Query Editor, where you can apply transformations and cleansing operations. 2. Removing duplicate data. Duplicate data can lead to incorrect analysis and inflated results. Power BI allows you to remove duplicate rows based on selected columns or entire rows. 2.1. Removing duplicates for entire rows. If your dataset contains exact duplicate rows, you can remove them in Power Query. Steps to remove duplicate rows. 1. In Power Query Editor, select the table that contains the duplicates. 2. Go to the Home tab. 3. Click on Remove Rows, remove duplicates. This action will remove rows where all column values are identical across the dataset. 4. Power Query will now display only unique rows. Example, if you have a sales table where some records are duplicated, you can select the table and click Remove Duplicates. Power Query will remove rows where all column values, for example, customer ID, order date, product ID, are identical. 2.2. Removing duplicates from specific columns. If you want to remove duplicates based on specific columns, for example, only unique customer IDs, Power Query allows you to target those columns. Steps to remove duplicates from specific columns. 1. In Power Query Editor, select the column S where duplicates exist. You can select multiple columns by holding Ctrl and clicking on the column headers. 2. Go to the Home tab and click on Remove Duplicates. This will keep only the first occurrence of each unique value based on the selected columns, removing any additional rows with the same values in those columns. Example, if you want to keep only one entry per customer in a dataset with duplicate customer records, select the Customer ID column and choose Remove Duplicates. Power Query will keep the first instance of each customer and remove the rest. 3. Handling null or missing values. Null or missing values can lead to incomplete analysis, broken calculations, or distorted visuals. Power BI provides various options to handle null values, including replacing, filling, or removing them. 3.1. Replacing null values with default values. In many cases, you might want to replace null values with a default value, for example, 0 for numerical columns, unknown for text columns. Steps to replace null values. 1. In Power Query Editor, select the column that contains null values. 2. Go to the Transform tab and click on Replace Values. 3. In the dialog box, enter null as the value to find. 4. Enter the replacement value, for example, 0, unknown in the Replace with box. 5. Click OK to apply the changes. Example, if a sales column contains null values, you can replace them with 0 to ensure calculations such as sums or averages aren't affected by missing data. Select the sales column, use Replace Values, and replace null with 0. 3.2. Filling missing values from adjacent rows. In some datasets, missing values in a column may be inferred from adjacent rows. For example, when a value is missing in a series but appears in the previous or next row. Steps to fill missing values. 1. Select the column with missing values in Power Query Editor. 2. Go to the Transform tab. 3. Click on Fill and choose Down fills null values with the value from the row above, or Up fills null values with the value from the row below. Example, if you're working with a dataset where a region column has null values for some rows, you can fill down the region from previous rows to ensure consistency in reporting. 3.3. Removing rows with null values. In cases where null values are not acceptable, you can remove rows containing nulls from the dataset. Steps to remove rows with null values. 1. In Power Query Editor, select the column S that contain null values. 2. Go to the Home tab. 3. Click on Remove Rows, remove blank rows to remove rows where all values are null or remove rows, remove errors to remove rows containing errors or nulls in a specific column. 4. This will remove any rows that have null values in the selected columns. Example: if you're working with a financial dataset where some records contain null values for essential fields like transaction amount, you can remove those rows entirely. Select the transaction amount column and choose Remove Rows. Remove blank rows. 4. Standardizing and formatting data. After handling duplicates and missing values, it's often necessary to standardize or format your data to ensure consistency. 4.1. Trim and clean text columns. Text columns may contain extra spaces or non-printable characters, which can affect data quality. You can clean and trim text columns to remove these unwanted characters. Steps to clean and trim text. 1. In Power Query Editor, select the text column you want to clean. 2. Go to the Transform tab. 3. Click on Format Trim, removes leading and trailing spaces, or Clean removes non-printable characters. 4. This ensures that your text data is clean and ready for analysis. Example: if a customer name column contains extra spaces around the names, for example, John Doe, you can use the Trim option to remove these spaces and ensure the data is clean. 4.2. Standardized date formats. Date columns often come in different formats, for example, Media YYYY or DDYYYY. You can standardize the date format in Power BI to ensure consistent date representations. Steps to standardize date formats. 1. In Power Query Editor, select the column that contains dates. 2. Go to the Transform tab and click Data Type DateTime. 3. Power Query will convert the dates into a standardized format that is suitable for time intelligence calculations in Power BI. Example: if your dataset has dates in multiple formats, converting them to a single standard format, for example, YYYYMDD, ensures that Power BI can recognize and use them correctly in calculations. 5. Applying and saving transformations. Once you've removed duplicates, handled null values, and standardized your data, the final step is to apply the changes and load the data back into Power BI. Steps to apply and save changes. 1. After completing your data cleansing steps, click Close and Apply in Power Query Editor. 2. Power BI will apply the transformations and load the cleaned data into the data model. 3. You can now use the cleansed data for further analysis, visualization, or reporting. Summary: by removing duplicate data and handling null values effectively in Power BI, you can ensure that your dataset is clean and reliable for accurate analysis. Applying these cleansing techniques is critical for producing high-quality reports and dashboards, and mastering them will help you succeed in the PL300 certification exam. Profile the data for accuracy and consistency. Deep Dive Tutorial. Profile the data for accuracy and consistency in Power BI. Data profiling in Power BI ensures that the data you're working with is accurate, consistent, and ready for analysis. Power BI provides several tools in the Power Query Editor to help you understand the distribution, quality, and overall structure of your data. Profiling is crucial to detect anomalies such as incorrect data types, missing values, outliers, and inconsistencies. This tutorial walks you through the steps to profile data for accuracy and consistency using Power Query Editor. 1. What is data profiling? Data profiling involves analyzing the structure, quality, and content of your data to ensure it is accurate and consistent. Key aspects of data profiling include column quality, identifying errors, missing values, and valid entries. Column distribution, understanding the frequency and distribution of values. Column statistics, generating summary statistics like minimum, maximum, and average values. Benefits of data profiling: helps ensure the data is complete and ready for reporting. Identifies potential issues with data accuracy and consistency, for example, outliers, missing values. Enables better decision-making about transformations needed for data cleansing. 2. Enabling data profiling in Power Query Editor. 2.1. Accessing Power Query Editor. 1. Open Power BI Desktop. 2. Navigate to the Home tab and select Transform Data to open the Power Query Editor. 2.2. Enabling data profiling options. Power BI offers several data profiling features. You can enable them by following these steps. 1. In Power Query Editor, go to the View tab. 2. Check the following options. Column quality displays the percentage of valid, error, and empty null values for each column. Column distribution displays a histogram showing the distribution of unique and distinct values in each column. Column profile displays detailed statistics, including minimum, maximum, average, and value distribution for each column. 3. Using data profiling tools. 3.1. Column quality. The column quality feature provides a quick overview of the data's validity. It shows valid, the percentage of rows that contain valid data. Error, the percentage of rows with errors, for example, data type mismatch. Empty, the percentage of rows with null or missing values. Steps to view column quality. 1. In Power Query Editor, ensure the column quality option is checked under the View tab. 2. For each column, a small visual bar will appear below the column header, indicating the proportion of valid, error, and empty values. 3. Use this information to assess whether a column has missing values or errors that need to be addressed. Example, if a column shows 10% empty, it may indicate missing data that needs to be filled or handled through transformations. 3.2. Column distribution. The column distribution feature provides a histogram-like view of the unique and distinct values in each column. This helps identify outliers, frequently occurring values, or categories that dominate the dataset. Steps to view column distribution. 1. In Power Query Editor, ensure the column distribution option is checked under the View tab. 2. The histogram under each column header shows the distribution of values in that column. It displays unique values, the number of unique values in the column. Distinct values, the number of distinct non-repeated values. Example, if a column shows only one distinct value across a large dataset, it may not add value to the analysis and could be removed. If a column has a large number of unique values, for example, customer ID, it may need further investigation for consistency. 3.3. Column profile. The column profile feature provides detailed statistics about a column, including min, max, and average. Helps identify outliers and ensure data is within expected ranges. Count of unique and distinct values shows the variety of data in the column. Value distribution displays how data is spread across the range of possible values. Steps to view column profile. 1. Select a column to profile. 2. In the View tab, ensure the column profile option is checked. 3. The column profile pane at the bottom of the window will show detailed information for the selected column, including minimum and maximum values, mean average, count of distinct and unique values, a distribution chart showing the most common values. Example, in a sales table, the column profile for the sales amount column shows the minimum and maximum sales figures, helping to detect outliers such as unexpectedly high or low sales amounts. In a date column, the profile may highlight gaps in data, for example, missing dates, helping you decide whether to fill in those gaps or remove the rows. 4. Profiling numeric data. Numeric columns often require profiling to detect outliers or incorrect values. Steps to profile numeric data. 1. Select the numeric column you want to profile. 2. View the column profile section to check for min and max. These values should fall within the expected range. Mean. This gives you the average, which helps check if the distribution is balanced. Distribution. The distribution chart can highlight whether the data is skewed or has outliers. Example, In a dataset tracking employee salaries, if the minimum value is far below expectations, for example, $0 or negative, it might indicate incorrect data or missing values. 5. Profiling categorical data. For columns containing categorical data, for example, product names, regions, or customer categories, understanding the variety of values and their distribution is essential for accurate analysis. Steps to profile categorical data. 1. Select a categorical column, for example, product name or country. 2. In the column profile pane, check the distribution of values. Power BI will display the frequency of each value. 3. Pay attention to most common values. Identify if a few categories dominate the dataset. Outliers. Look for rare or unexpected categories that may need investigation. Null empty values. Ensure there aren't missing categories, which could indicate incomplete data. Example, if profiling a column containing customer regions, the column profile shows that North America accounts for 80% of the entries, while other regions like Asia or Europe account for far fewer. You can use this insight to focus your analysis on the key regions or address imbalances in the dataset. 6. Dealing with profiling issues. When profiling reveals issues such as missing or incorrect data, you need to take corrective action. 6.1. Handling outliers. If profiling shows outliers in numeric data, for example, a few extremely high or low values, you can remove or filter out outliers. Use Power Query to filter out values outside a given range. Correct data. If you know the correct values, manually update them or replace them with more reasonable estimates. 6.2. Handling inconsistent data. For inconsistent data, for example, inconsistent spellings of categorical values like USA versus United States, you can use the Replace Values feature in Power Query to standardize values. Use Group By to aggregate data and ensure consistency across grouped categories. 6.3. Handling missing data. Profiling often reveals missing data. You can fill missing values. Use the Fill Down or Fill Up options to fill missing values based on adjacent rows. Replace nulls. Replace null values with a default value using Replace Values. 7. Applying and saving changes. After profiling your data and making necessary corrections, you need to apply the changes and load the data back into Power BI. Steps to apply changes. 1. After completing your data profiling and corrections, click Close and apply in the Power Query Editor. 2. Power BI will apply the transformations and profiling corrections, loading the cleansed and profiled data into the data model. Conclusion. Data profiling is an essential part of data preparation in Power BI. By leveraging the column quality, column distribution, and column profile features, you can ensure that your data is accurate, consistent, and ready for analysis. Proper profiling helps you identify and correct errors early in the process, leading to more reliable insights and better performance in reports. This skill is crucial for achieving success in the PL300 certification exam. Resolve inconsistencies, incorrect formats, or missing data. Deep Dive Tutorial. Resolve inconsistencies, incorrect formats, or missing data in Power BI. Handling data inconsistencies, incorrect formats, and missing data is a crucial part of preparing your dataset for analysis in Power BI. These issues can lead to incorrect conclusions or broken reports if not addressed properly. In this tutorial, we'll explore how to resolve these problems using Power Query Editor in Power BI. 1. Accessing Power Query Editor. All transformations and data cleansing tasks in Power BI are performed using Power Query Editor. To start resolving data issues, you first need to access this tool. Steps to open Power Query Editor. 1. Open Power BI Desktop. 2. Navigate to the Home tab and select Transform Data. 3. This opens the Power Query Editor window, where you can apply transformations and clean your data. 2. Resolving inconsistencies. Inconsistent data can arise from issues like varying spellings, inconsistent formats, or irregular units of measure. Power BI provides several tools to standardize and clean such data. 2.1. Standardizing categorical data. When working with categorical data, for example, country names, product categories, etc., inconsistent spelling or formatting can cause problems with analysis. For instance, USA, United States, and US might all represent the same entity, but are treated as different categories. Steps to resolve inconsistent values. 1. In Power Query Editor, select the column with inconsistent values, for example, country. 2. Use the Replace Values feature. Go to Transform Replace Values. Enter the incorrect value, for example, US, and the correct value, for example, United States. Click OK to apply the change. Example: you might find several variations of United States, for example, USA, USA, United States. You can select the country column and use replace values to standardize all variations to United States. 2.2. Using conditional columns. If the inconsistencies are more complex, you can create conditional logic to handle them. Steps to create a conditional column. 1. In Power Query Editor, go to the Add Column tab and click Conditional Column. 2. Define the condition based on inconsistent values. For example, if the value is US or USA, set it to United States. 3. Click OK to create the new column with consistent values. Example: if a product category has inconsistent labels, for example, T-shirts versus shirts, you can create a conditional column that standardizes these to a common label, for example, T-shirts. 3. Resolving incorrect formats. Incorrect data formats can lead to errors in calculations or broken visualizations. For example, dates stored as text or numbers stored as strings won't behave correctly in time intelligence functions or aggregations. 3.1. Correcting data types. Ensuring that each column has the correct data type is essential for proper data modeling. Steps to change data types. 1. In Power Query Editor, select the column you need to reformat. 2. Go to the Transform tab and click Data Type. 3. Choose the appropriate data type from the list, for example, date, whole number, decimal, text. You can also right-click the column header and select Change Type. Example: if a column containing sales amounts is stored as text, select the column and change the data type to decimal number to enable proper summing and calculations. 3.2. Parsing text to columns. Sometimes data is incorrectly stored in a single column, such as first and last names stored together. You can split this data into multiple columns. Steps to split columns. 1. Select the column you want to split. 2. Go to Transform Split Column and choose the appropriate delimiter, for example, space, comma. 3. Power Query will split the column based on the delimiter and create new columns. Example: if a full name column contains both first and last names, use the Split Column feature to separate them into two columns, first name, last name. 3.3. Standardizing date formats. Dates can come in various formats, such as DDYYYY or DDYYYY, and may need to be standardized. Steps to standardize date formats. 1. Select the date column. 2. Go to Transform Data Type Datetime. 3. Power BI will convert the values to a standard date format that is compatible with date-based calculations and visualizations. Example: if a date column is stored as text, 31st December 2023, changing the data type to date will allow Power BI to recognize it as a valid date for time intelligence calculations. 4. Handling missing data. Missing data null values can cause issues when generating reports and performing calculations. Power BI provides multiple options for handling missing data, including filling, replacing, or removing null values. 4.1. Replacing null values with defaults. You can replace missing or null values with default values to avoid errors in calculations and visualizations. Steps to replace null values. 1. Select the column that contains null values. 2. Go to the Transform tab and click Replace Values. 3. Enter null in the value to find box. 4. Enter the replacement value, for example, 0 for numeric columns, unknown for text columns in the Replace with box. 5. Click OK to apply the changes. Example: in a sales table, if some rows have missing sales amounts, you can replace null values in the sales amount column with 0 to ensure that calculations like totals or averages are not affected by the missing data. 4.2. Filling missing values. When working with time series or sequential data, you may need to fill missing values based on adjacent rows, for example, carrying forward the previous value. Steps to fill missing values. 1. Select the column with missing values. 2. Go to Transform Fill Down to fill missing values with the value from the previous row, or up to fill missing values with the value from the next row. Example: if a region column contains missing values for some rows, you can fill those missing values with the last valid region value using Fill Down. 4.3. Removing rows with null values. In some cases, you may need to remove rows that contain null or incomplete data, especially if these rows don't contribute to your analysis. Steps to remove rows with null values. 1. Select the column S with null values. 2. Go to the Home tab and click Remove Rows. Remove blank rows. This will remove all rows where the selected column contains a null or blank value. 3. Alternatively, go to Home, Remove Rows, Remove Errors to remove rows that contain errors. Example: if an email address column contains null values for some rows, you might want to remove these rows entirely if an email address is a critical field for your analysis. 5. Handling errors in data. Sometimes errors may occur during data import or transformation due to incorrect data types or calculations. These errors need to be resolved for the dataset to load correctly. 5.1. Identifying errors. Power Query highlights errors in your data transformation steps. You can identify them easily by checking for red cells or using Remove Errors. Steps to identify and handle errors. 1. In Power Query Editor, error values are indicated with a red warning icon. 2. Select the column with errors, right-click, and choose Remove Errors. This removes rows that contain errors in the selected column. 3. Alternatively, use Replace Errors to substitute error values with valid values. For example, replace errors in a numeric column with 0. Example: if a calculation results in an error, for example, division by 0, you can either remove the row or replace the error with a default value. 6. Applying and saving transformations. Once you have resolved all inconsistencies, incorrect formats, and missing data, the final step is to apply the transformations and load the cleaned data into Power BI. Steps to apply changes. 1. After performing all data cleansing and transformations, click Close and apply in the Power Query Editor. 2. Power BI will apply the transformations and load the cleaned data into the data model. 3. You can now use the cleaned and consistent dataset for further analysis, visualizations, and reporting. Summary: resolving inconsistencies, incorrect formats, and missing data is essential for ensuring your dataset is ready for accurate analysis in Power BI. By using the tools provided in Power Query Editor, you can standardize data, correct formatting issues, handle missing values, and ensure that your reports run smoothly without errors. These data preparation techniques are vital for success in the PL300 certification exam and for effective data analysis in Power BI. Load the transformed data into Power BI. Deep Dive Tutorial. Load the transformed data into Power BI. Once you've cleaned, transformed, and prepared your data using Power Query in Power BI, The next crucial step is to load the transformed data into Power BI's data model. This allows you to use the cleaned data for reporting, visualizations, and further analysis. In this tutorial, we'll cover how to load the data after transformations, explore different loading options, and troubleshoot common issues. 1. Loading transformed data into Power BI. After applying transformations, Power BI provides several options for loading data into the model, including directly loading into memory or using more advanced techniques like direct query or live connections. 1.1. Steps to load data into Power BI. 1. Once you have completed your data transformations in the Power Query Editor, click Close and Apply from the top left corner of the Power Query Editor window. 2. Power BI will begin the process of applying the transformations and loading the data into the data model. 3. A progress window will appear showing the data load status, including the number of rows being loaded, any errors, or warnings. 4. Once the data load is complete, the data will be available in Power BI Desktop for use in reports, dashboards, and visualizations. 1.2. Key considerations during data load. Memory usage. If you are working in import mode, Power BI loads the data into memory in Memory Analytics Engine. Ensure your system has enough memory to handle the dataset size. Data refresh. If you plan to refresh the dataset periodically, configure appropriate refresh settings in Power BI Service for scheduled refreshes or use direct query to ensure real-time data access. 2. Data load modes. Import versus direct query. Before loading data, it's important to understand the differences between import mode and direct query mode, as each has performance and usage implications. 2.1. Import mode. How it works. The data is loaded into Power BI's in-memory storage, and all analysis is done on the imported dataset. Advantages. Fast performance as the data is stored locally, and you don't need to query the source every time a visual is updated. Disadvantages. Large datasets can cause memory usage issues, and the data can become outdated unless regularly refreshed. When to use import mode. When the dataset is small to medium sized. When you need to work offline or create reports that don't require real-time data. How to load in import mode. 1. In Power Query, complete your transformations. 2. Click Close and Apply to load the data into memory default setting. 2.2. Direct Query Mode. How it works. Instead of importing data, Power BI sends queries directly to the data source each time you interact with a visual. Advantages. Always accesses real-time data, and you can work with very large datasets without exceeding memory limits. Disadvantages. Query performance is slower because it depends on the source database, and more complex visuals may take longer to update. When to use direct query mode. When working with large datasets that cannot fit into memory. When real-time or near real-time data is required for reporting. How to load in direct query mode. 1. When you connect to a data source in Get Data, choose the direct query option. 2. Apply your transformations and click Close and Apply. Power BI will send queries to the database when visuals are refreshed. 3. Incremental data load. For large datasets, loading the entire dataset every time you refresh can be inefficient. Power BI's incremental refresh allows you to load only the changes new or updated data rather than the entire dataset. 3.1. Setting up incremental refresh. 1. Go to the Manage Parameters option in Power Query. 2. Create two parameters, range start and range gained, which define the time window for the data refresh. 3. Filter your dataset in Power Query using these parameters. 4. Publish the dataset to Power BI Service. 5. In Power BI Service, configure the incremental refresh policy under Dataset Settings. Benefits of incremental refresh. Improved performance, especially with large datasets. Reduces load times since only new data is refreshed. 4. Loading data into Power BI Data Model. Once data is loaded into Power BI, it becomes part of the data model. The Power BI data model allows you to build relationships between tables, define measures and calculated columns, and create hierarchies. 4.1. Viewing the data in Power BI. After the data load is complete, you can view the data in different views in Power BI Desktop. Data View shows a tabular format of the loaded data. You can inspect each column and row for verification. Model View displays the relationships between different tables in the data model. Steps to view data in Power BI. 1. After loading the data, switch to the Data View by clicking on the data icon in the left panel. 2. You can now inspect the data tables and perform further operations like creating measures and calculated columns. 3. In the Model View, you can create or adjust relationships between tables and define data hierarchies. 5. Configuring data refresh in Power BI Service. Once the dataset is published to Power BI Service, you can configure automatic data refreshes to ensure your reports are always up to date. 5.1. Steps to configure data refresh. 1. Publish the Power BI report to the Power BI Service. 2. Navigate to the dataset in Power BI Service. 3. Click on the ellipsis next to the dataset and select Settings. 4. Under the Scheduled Refresh section, configure the refresh frequency daily, weekly, etc., and provide the credentials for connecting to the data source. 5. Save the settings, and Power BI Service will now refresh the dataset at the specified intervals. 5.2. Data Gateway. If your data source is on premises, you'll need to install and configure a data gateway to allow Power BI Service to access the source. 6. Troubleshooting data load issues. 6.1. Common issues and solutions. Issue 1. Data load errors. Cause: mismatched data types, connectivity issues, or large dataset size. Solution: review the error messages during the load process. Check column data types, especially in complex transformations. If working with large datasets, consider filtering the data before loading. Issue 2. Memory limits exceeded. Cause: large datasets may cause memory issues when loading in import mode. Solution: optimize the data model by removing unnecessary columns and rows, or switch to direct query mode. Issue 3. Slow load time. Cause: complex transformations or working with a large dataset in direct query mode. Solution: simplify transformations in Power Query or aggregate the data at the source before loading. For direct query mode, ensure the database is optimized. For example, indexes are properly set up. 7. Applying changes and saving the data. 7.1. Finalizing the data load. Once Power BI has successfully loaded the data. 1. You can now build visualizations, reports, and dashboards. 2. Use the loaded data to create measures, calculated columns, and relationships between tables. 7.2. Saving the Power BI report. 1. Click File Save As and choose a location to save your Power BI report PBIX file. 2. The file contains the data model, report design, and loaded data, allowing you to reopen and continue working with the dataset. Conclusion: loading transformed data into Power BI is the final step in the data preparation process and sets the stage for analysis and reporting. Whether you use import mode, direct query, or incremental refresh, understanding how to manage data loads efficiently is essential for performance and accuracy in your Power BI reports. With these techniques, you can ensure that your data is clean, optimized, and ready for further analysis, helping you succeed in the PL300 certification exam. Define relationships between tables using the right cardinality and direction. Deep dive tutorial. Define relationships between tables using the right cardinality and direction in Power BI. In Power BI, relationships between tables play a critical role in how data is modeled, analyzed, and visualized. A well-defined relationship ensures that the data from multiple tables can be properly combined and analyzed. This tutorial will cover how to define relationships between tables using the correct cardinality and direction. 1. What are relationships in Power BI? A relationship in Power BI connects two or more tables by linking columns keys that share a common value. Relationships allow Power BI to combine the data from different tables into one coherent data model for analysis. There are several key aspects to consider when defining relationships. Cardinality defines how many rows in one table relate to how many rows in another table, one-to-one, one-to-many, many-to-many. Cross-filter direction controls how filters applied in one table affect related table, single direction, or bidirectional. Active and inactive relationships. You can define multiple relationships between two tables, but only one relationship can be active at a time. 2. Understanding cardinality. Cardinality refers to the type of relationship between the tables, typically 1-to-1, 1. 1. Each row in one table corresponds to exactly one row in another table. 1-to-many, 1. A row in one table can relate to multiple rows in another table. Many-to-one n, 1. The inverse of a one-to-many relationship. Many-to-many n. Rows in both tables can have multiple matching rows in the other table. 2.1. 1-to-1, 1. One relationship. A one-to-one relationship means that each row in table A has exactly one corresponding row in table B. When to use. When two tables share a primary key, and both tables have unique entries for that key. Example, you have a customer table and a customer details table, and each customer appears exactly once in both tables. The customer in field is the unique key for both tables. 2.2. One-to-many, 1. Relationship. A one-to-many relationship means that a single row in table A can relate to multiple rows in table B. When to use. When one table contains unique entries, for example, a dimension or lookup table, and the other table contains multiple related records, for example, a fact table. Example, you have a product table 1 and a sales table many. Each product can appear multiple times in the sales table, but each product appears only once in the product table. 2.3. Many-to-many relationship. A many-to-many relationship means that multiple rows in table A can relate to multiple rows in table B. When to use. When neither table has unique values for the key column and multiple matching rows exist in both tables. Example, you have a students table and a courses table. Each student can enroll in multiple courses, and each course can have multiple students. 3. Creating relationships in Power BI. Power BI can automatically detect relationships between tables based on matching column names and data types. But you can also manually define relationships. Steps to define a relationship in Power BI. 1. Open Power BI Desktop and go to the model view by clicking the model icon on the left pane. 2. If Power BI hasn't already detected the relationship, drag and drop the common field from one table to the other. 3. A dialog box will appear allowing you to configure the relationship. Configuring the relationship. Cardinality. Choose the cardinality 1-to-1, 1-to-many, or many-to-many based on the nature of the data. Cross-filter direction. Choose single or both depending on how you want filters to propagate between tables. Active relationship. Check if this is the active relationship, especially if there are multiple relationships between tables. Example, you have a customer table and a sales table. Both tables share a common field called customered. You can create a one-to-many relationship between customer table 1 and sales table many, as each customer can have multiple sales records. 4. Choosing the right cross-filter direction. Cross-filter direction controls how filtering affects tables within your model. There are two main options. Single directional filtering. Filters applied in the one side of the relationship filter the many side, but not vice versa. Bidirectional filtering. Filters flow in both directions between the tables. 4.1. Single direction default. In a single direction relationship, the filtering is applied from the one side to the many side, but not the other way around. This is the default behavior in Power BI and is the safest option for performance and accuracy. When to use most scenarios, especially when working with dimension lookup tables and fact tables. Example, you have a product table 1 and a sales table many. If you filter by a product, it filters the sales records, but filtering by a specific sale won't filter the product table. 4.2. Bidirectional cross-filtering. In a bidirectional relationship, filters applied to either table affect both tables. This is useful for complex models where relationships need to propagate in both directions, but it can introduce ambiguity and performance issues in large models. When to use. When you need filters to flow in both directions between tables, for example, between fact tables. Example, if you have a customer table and a sales table, and you want to apply filters on both customers and sales simultaneously, for example, filtering by a sales amount to find customers who purchased over a certain value. Performance tip. Bidirectional relationships can slow down performance in large datasets. Use them only when necessary, and prefer single directional filtering when possible. 5. Multiple relationships between tables. Sometimes, you may need to create multiple relationships between the same two tables. Power BI allows you to define more than one relationship, but only one can be active at any time. 5.1. Active versus inactive relationships. Active relationship. The primary relationship used in calculations and visualizations. Inactive relationship. These relationships are not used by default, but can be activated in specific DAX formulas using the useRelationship function. Steps to create multiple relationships. 1. In Model View, create the primary relationship between the tables. 2. To create a second relationship, drag the corresponding field between tables. Power BI will create an inactive relationship. 3. In your DAX formulas, use the useRelationship function to activate the inactive relationship for specific calculations. Example, you have a sales table that is related to both the order date and the ship date in a calendar table. You can create two relationships, but only one. For example, the order date relationship can be active at a time. Use useRelationship in DAX when you need to calculate metrics based on the ship date. 6. Best practices for defining relationships. 6.1. Use star schema design. A star schema design fact table at the center, surrounded by dimension tables, helps you define relationships more efficiently. Dimension tables, for example, customer, product, date, should connect to the fact table, for example, sales, using a one-to-many relationship. Avoid snowflake schemas or complex relationship chains unless absolutely necessary. 6.2. Minimize bidirectional relationships. While bidirectional filtering can be useful, avoid overuse as it can slow down report performance. Use bidirectional relationships only when absolutely needed. 6.3. Ensure correct cardinality. Always check the data cardinality before defining relationships. For example, if a table contains unique values for a key, ensure the relationship is one-to-many rather than many-to-one. 6.4. Manage inactive relationships in DAX. Use useRelationship to manage inactive relationships explicitly in DAX calculations. This ensures that you can use multiple relationships effectively without creating ambiguity in your data model. Conclusion: defining relationships with the correct cardinality and direction is fundamental for building an efficient data model in Power BI. By understanding the different types of relationships, one-to-many, many-to-many, cardinality, and cross-filter direction, you can ensure that your data behaves as expected during analysis and reporting. This knowledge is essential for optimizing your Power BI models and is a key part of preparing for the PL300 certification exam. Optimize the model by designing star schemas. Deep Dive Tutorial. Optimize the model by designing star schemas in Power BI. A star schema is a data modeling approach that helps optimize the performance and usability of a Power BI data model. It provides a simple and efficient structure by organizing data into fact and dimension tables, reducing redundancy, improving query performance, and making it easier to understand the relationships in your data. In this tutorial, we will explore how to design a star schema in Power BI and optimize your data model. 1. What is a star schema? A star schema consists of fact table, a central table that contains the transactional or quantitative data, for example, sales, orders, revenue. Dimension tables, surrounding tables that contain descriptive information, for example, customer details, product information, date information related to the facts. The relationship between the fact and dimension tables is typically one-to-many. Each row in a dimension table can be linked to multiple rows in the fact table. Example of a star schema structure. Mathematica. Customer sales less than product. Vertical bar. V. Date. In this example, sales is the fact table containing transactional data such as sales amount, order date, and customer ID. Customer, product, and date are the dimension tables that describe the data in the fact table. 2. Benefits of using a star schema. Simplified data model. Clear and easy to understand relationships between fact and dimension tables. Optimized performance. Fewer joins and optimized queries due to the simplicity of the structure. Scalability. The star schema supports the efficient handling of large datasets by separating transactions fact table from attributes dimension tables. Improved DAX performance. Simplified data structure enables faster calculations and queries. 3. Designing a star schema in Power BI. To optimize your Power BI model using a star schema, you need to properly structure your data into fact and dimension tables. Here's how. 3.1. Identifying fact and dimension tables. Fact table. The table that stores transactional data, such as sales transactions, order details, or inventory changes. It contains quantitative data like sales amount, quantity sold, order date, customer ID, product ID. Foreign keys to dimension tables. Dimension tables. The tables that provide context to the facts, containing descriptive data about the transactions. Typical dimension tables include customer dimension, customer ID, name, address, segment. Product dimension, product ID, name, category, price. Date dimension, date, month, year, quarter. Example, sales table fact table contains transactional data like sales amount, order date, customer ID, and product ID. Customer table dimension table contains customer information like customer ID, customer name, region. Product table dimension table contains product information like product ID, product name, category. 3.2. Creating relationships in the star schema. Once you've identified your fact and dimension tables, the next step is to define the relationships between them. Steps to create relationships. 1. Go to the model view in Power BI Desktop. 2. Drag and drop fields between tables to create relationships. Link the foreign key in the fact table, for example, customer ID in sales table, to the primary key in the dimension table, for example, customer ID in the customer table. Define relationships as one-to-many. Each dimension one can relate to many rows in the fact table many. 3. Ensure that all fact tables are linked to the appropriate dimension tables and that relationships are correctly established. Example, in a sales table, the customer ID field is linked to the customer table's customer ID field in a one-to-many relationship. 3.3. Using a date dimension calendar table. A date dimension or calendar table is a critical part of a star schema, especially for time intelligence calculations. Instead of using raw date columns from your fact table, create a separate date dimension that contains useful date information, for example, year, quarter, month. Steps to create a date dimension. 1. Create a date table in Power BI. Go to Modeling, New Table. Use DAX to generate a date table. Dateable equal calendar date 2020, 1, 1, date 2023, 12, 31. 2. Add additional columns for year, month, quarter, etc. Year equal year date, month equal format date, MMMM, quarter equal Q and quarter date. 3. Link the date table to the fact table on the date field, ensuring a one-to-many relationship. Why use a date dimension? It enables time intelligence calculations, such as year-to-date YTD, month-to-date MTD, and quarter comparisons. Ensures consistent date handling across all visualizations and reports. 4. Best practices for star schema design. 4.1. Simplify relationships. Always aim for a one-to-many relationship between the fact table and dimension tables. Avoid many-to-many relationships unless absolutely necessary, as they can complicate the model and reduce performance. 4.2. Keep dimension tables separate. Avoid duplicating information in the fact table. For example, don't include detailed product descriptions in the fact table. Instead, keep them in the product dimension table. Dimension tables should only contain descriptive information and be as concise as possible. 4.3. Use surrogate keys. It's a best practice to use surrogate keys, unique identifiers in both fact and dimension tables to establish relationships. This ensures the relationships are clean and unambiguous. 4.4. Ensure referential integrity. Ensure that every fact table entry has a corresponding dimension table entry. For instance, every sale should have a valid customer ID, product ID, and date. 5. Optimizing performance with star schema. 5.1. Reducing data size. Remove unnecessary columns. In both fact and dimension tables, keep only the columns needed for analysis. Unused columns consume memory and slow down the model. Remove unnecessary rows. Filter your fact table to include only the necessary data, for example. Remove old data, or filter to include data for specific regions. 5.2. Aggregating data. Aggregate the data at a higher level when possible. Instead of keeping every single transaction in the fact table, consider grouping the data by day or month to reduce the number of rows. Example, instead of keeping every single sale transaction, aggregate the sales data by product ID, customer ID, and date, summing the sales amount for each day. 5.3. Indexing and pre-sorting. Ensure that the key fields in both fact and dimension tables, for example, customer ID, product ID, are indexed for faster joins. Pre-sort your tables based on key fields to optimize the performance of DAX calculations and relationships. 6. Avoiding snowflake schema. In a snowflake schema, dimension tables are normalized into subdimensions, creating more relationships and complexity. While this can reduce redundancy, it complicates the data model and often degrades performance. Why avoid snowflake schema? Snowflake schemas increase the number of joins, making queries slower and harder to maintain. Star schemas are simpler and better suited to Power BI, which favors models with fewer relationships and simpler structures. 7. Testing and monitoring performance. Once you have designed the star schema, test your model to ensure that it performs well. Use Power BI Performance Analyzer to monitor the performance of visuals and calculations. Ensure that your star schema reduces the complexity and improves query performance. Check for long-running queries or visuals that take time to refresh, and look for ways to simplify relationships or reduce data size. Conclusion: designing a star schema is one of the most effective ways to optimize a Power BI data model. It simplifies relationships, enhances performance, and ensures clarity in your data model. By organizing your data into fact and dimension tables, using one-to-many relationships, and following best practices for reducing data size and complexity, you can significantly improve the performance and usability of your reports. Mastering these techniques is essential for the PL300 certification exam and for creating efficient Power BI solutions in real-world projects. Configure role-playing dimensions and hierarchies in the data model. Deep Dive Tutorial. Configure role-playing dimensions and hierarchies in the Power BI data model. In Power BI, role-playing dimensions and hierarchies are powerful techniques used to model data for more complex and flexible analysis. Role-playing dimensions allow a single dimension table to be reused multiple times with different relationships, while hierarchies help organize data for drill-down analysis. This tutorial will cover how to configure role-playing dimensions and create hierarchies in your Power BI data model. 1. What are role-playing dimensions? A role-playing dimension is a dimension table that can be used in multiple contexts within the same data model. For example, a date dimension can be used to represent different aspects of time in a fact table, such as order date, ship date, and due date. 1.1. Example of a role-playing dimension. A date dimension can be linked to multiple date fields in a fact table. Order date, when the order was placed. Ship date, when the order was shipped. Due date, when the order is expected to be delivered. Instead of creating multiple date tables, a single date dimension can be used multiple times in different roles. 2. Configuring role-playing dimensions in Power BI. 2.1. Step 1. Create a date dimension table. First, create a date dimension or use an existing one. This table should contain all the necessary date fields, such as year, quarter, month, and day. Steps to create a date dimension. 1. Open Power BI Desktop. 2. Go to Modeling New Table. 3. Use DAX to create a date dimension. Data double equal calendar date 2020, 1, 1, date 2025, 12, 31. 4. Add calculated columns for year, month, quarter, etc. Year equal year date. Month equal format date. MMM. Quarter equal Q and quarter date. 2.2. Step 2. Create multiple relationships. You need to establish multiple relationships between the date dimension and the fact table, for example. Sales table based on the different date fields, for example. Order date, ship date, and due date. Steps to create multiple relationships. 1. Go to the Model view in Power BI Desktop. 2. Drag the date field from the date dimension to the corresponding date field in the sales table, for example, order date, ship date. 3. Power BI will allow you to create multiple relationships, but only one active relationship at a time. 2.3. Step 3. Manage active and inactive relationships. Power BI allows you to define multiple relationships between the same two tables, but only one relationship can be active at a time. The active relationship is used by default in visuals and calculations, but you can use DAX to work with inactive relationships. Steps to manage active and inactive relationships. 1. When creating a relationship between date and the fact table, specify which relationship should be active. By default, Power BI activates the first relationship created. 2. Use the Manage Relationships pane to manually activate or deactivate relationships. 2.4. Step 4. Use DAX to activate inactive relationships. To use an inactive relationship in calculations or measures, you can activate it using the Use Relationship DAX function. This allows you to create different measures that reference different date fields. Example DAX formula: order date sales. Order date equal calculate sum sales amount, use relationship sales order date, data double date. Ship date sales. Ship data sales equal calculate sum sales amount, use relationship sales ship date, data double date. By using use relationship, you can leverage different relationships for the same date dimension to calculate measures based on different date fields. 3. What are hierarchies in Power BI? A hierarchy in Power BI organizes data in a multi-level structure that allows users to drill down from higher to lower levels of granularity. For example, a date hierarchy might allow users to drill down from year to quarter, month, and day. Hierarchies make it easy to navigate large data sets and visualize data at different levels of detail in reports and dashboards. 3.1. Example of a hierarchy. A date hierarchy could have the following levels: year, quarter, month, day. 4. Creating hierarchies in Power BI. 4.1. Step 1. Identify hierarchy levels. First, identify the levels you want to include in the hierarchy. Common hierarchies include date hierarchy, year, quarter, month, day; product hierarchy, category, subcategory, product name; geography hierarchy, country, state, province, city. 4.2. Step 2. Create the hierarchy in Power BI. Steps to create a hierarchy. 1. In the Model View or Data View, locate the table that contains the fields for the hierarchy. 2. Right-click the column that will be the top level of the hierarchy, for example, year in a date hierarchy, and select Create Hierarchy. 3. A new hierarchy will be created, and the selected column will be the top level. 4. Drag and drop the other columns, for example, quarter, month, day, into the hierarchy to create a multi-level structure. 4.3. Step 3. Use the hierarchy in Visuals. Once the hierarchy is created, you can use it in Visuals for easy drill-down functionality. Steps to use a hierarchy. 1. Drag the hierarchy into a visualization, for example, a bar chart or table. 2. You will see a small plus icon next to the top level, for example, year. Clicking on the plus icon allows users to drill down to the next level, for example, from year to quarter. 3. You can also right-click the visual and choose Drill Down or Drill Up to navigate through the hierarchy levels. Example of hierarchy usage. If you're displaying sales data over time, you can create a date hierarchy year, quarter, month, day. This allows users to start with an annual view of sales, then drill down to quarterly, monthly, or daily sales figures for a more detailed analysis. 5. Best practices for role-playing dimensions and hierarchies. 5.1. Use role-playing dimensions for flexibility. Role-playing dimensions, for example, date dimension used for multiple purposes, help avoid redundancy by reusing the same dimension table in different roles. Make sure to carefully manage relationships active versus inactive, and use relationship in DAX formulas to ensure the correct relationship is used. 5.2. Create meaningful and intuitive hierarchies. Keep hierarchies intuitive and meaningful to the user. For example, in a geography hierarchy, make sure the levels follow a logical order, for example, country, state, city. Limit the number of levels to avoid overwhelming users with too much detail. Users should be able to drill down progressively, but the hierarchy should remain simple. 5.3. Avoid overcomplicating the model. While role-playing dimensions and hierarchies are powerful, using too many can overcomplicate the model. Ensure that each relationship and hierarchy serves a clear purpose and simplifies the user experience. Where possible, consolidate dimensions or hierarchies to avoid confusion. 6. Troubleshooting and performance tips. 6.1. Performance considerations for role-playing dimensions. Multiple relationships can increase the complexity of the model and slow down performance, especially with large datasets. Ensure that inactive relationships are only used when necessary and that bidirectional filtering is used sparingly. 6.2. Performance considerations for hierarchies. Hierarchies with too many levels or extremely granular data, for example, down to the second, can slow down visuals and reports. If performance is an issue, consider reducing the number of hierarchy levels or pre-aggregating data to higher levels, for example, monthly instead of daily data. Conclusion. Configuring role-playing dimensions and hierarchies in Power BI helps you create a more flexible, scalable, and user-friendly data model. Role-playing dimensions allow a single dimension to be reused in different roles, for example, multiple date fields in a fact table, while hierarchies provide intuitive drill-down functionality for detailed analysis. These techniques are essential for optimizing your data model, enhancing the user experience, and preparing for complex real-world reporting scenarios, as well as excelling in the PL300 certification exam. Implement appropriate levels of granularity for data analysis. Deep Dive Tutorial. Implement appropriate levels of granularity for data analysis in Power BI. Granularity refers to the level of detail present in your data. For effective data analysis in Power BI, it's crucial to implement the right level of granularity based on the context of your analysis. Choosing the appropriate granularity allows you to balance performance, data accuracy, and the ability to drill into meaningful insights. In this tutorial, we will explore how to implement and manage different levels of granularity in Power BI for optimal data analysis. 1. Understanding granularity in data analysis. Granularity defines the level of detail represented in a dataset. Higher granularity refers to more detailed data, such as individual transactions or daily sales figures. Lower granularity refers to more aggregated data, such as monthly or yearly sales. 1.1. Examples of granularity. High granularity. A dataset that tracks each transaction or order with detailed information such as transaction time, product, customer, and region. Low granularity. A dataset that aggregates sales data by day, month, or year. Choosing the right granularity depends on the scope of your analysis. Performance considerations. Lower granularity improves performance. The depth of insights required. Higher granularity offers more detailed analysis. 2. Identifying appropriate levels of granularity for your data model. When implementing granularity in Power BI, it's important to think about the business context and how the data will be used for analysis. 2.1. Examples of business scenarios and granularity. 1. Daily sales reporting. High granularity. Individual sales transactions with details like product, customer, and time of sale. Low granularity. Daily aggregated sales totals by product or region. 2. Yearly revenue tracking. High granularity. Tracking monthly or quarterly revenue growth. Low granularity. Aggregated annual revenue totals by product category. 3. Customer lifetime value. High granularity. Track each customer interaction, for example, each transaction, website visit, or service interaction. Low granularity. Aggregate customer behavior data, for example, total purchases per year or quarter. Choosing the right level of granularity will help balance data detail and performance. 3. Implementing granularity in Power BI. 3.1. Aggregating data for lower granularity. Lowering the granularity by aggregating data helps improve performance, especially when dealing with large datasets. Aggregation can be performed either in the source database, during data import, or within Power BI using Power Query. Steps to aggregate data in Power Query. 1. Open Power Query Editor. 2. Select the table that contains the detailed data. 3. Go to the Transform tab and click Group By to aggregate the data. 4. In the Group By dialog box, choose the columns to group by, for example, date, product, customer, and the aggregation function, for example, sum, count, average. Example, group by date and product ID. Then sum the sales amount to get daily sales totals for each product. 5. Click OK to apply the aggregation. Example of aggregating sales data: original data, transaction level data with transaction ID, product ID, sales amount, customer ID, and transaction date. Aggregated data: group by product ID and transaction date, and sum the sales amount to get daily product sales. Before aggregation: date produced sales amount: 1st January 2024 P1 100, 1st January 2024 P1 200, 1st January 2024 P2 150. After aggregation: date produced total sales: 1st January 2024 P1 300, 1st January 2024 P2 150. 3.2. Maintaining high granularity for detailed analysis. For analyses that require detailed insights, maintaining high granularity in your dataset is necessary. This could include transaction-level data for sales, interaction-level data for customer behaviors. To implement high granularity, Import or maintain detailed tables in your data model without pre-aggregating them. Use filters, slicers, or hierarchies in Power BI reports to drill down into the data. Example of high granularity data. Sales transactions table. Each row represents an individual sale, including transaction ID, product ID, sales amount, customer ID, and transaction date. High granularity allows you to perform more granular analysis, such as viewing the number of transactions per customer per day. 4. Using multiple levels of granularity. In many cases, you may need to support multiple levels of granularity within the same data model. Power BI allows you to create aggregated tables at lower granularity for performance optimization, while still keeping detailed tables for granular analysis. 4.1. Aggregated tables for performance. Steps to create aggregated tables in Power BI. 1. In Power Query Editor, load the detailed fact table, for example, sales table. 2. Create an aggregated version of the fact table by grouping data in Power Query. Group by year and product to calculate yearly product sales totals. 3. Load both the detailed and aggregated tables into Power BI. 4. Use switching measures or drill-throughs to enable users to switch between different granularities. Example, detailed sales table contains daily transaction level data. Aggregated sales table contains yearly or monthly sales totals by product. In the report, you can display the yearly sales totals from the aggregated table, but allow users to drill down into individual transactions using the detailed sales table. 4.2. Using DAX to handle granularity. You can use DAX to create calculated measures that work at different levels of granularity. Example, create a total sales measure with DAX. Total sales equals sum sales amount. This measure can be used to calculate total sales at any level of granularity, whether daily, monthly, or yearly, depending on how you aggregate or filter your data in the visuals. Example, create a monthly sales measure with DAX. Monthly sales equal calculate sum sales amount. Dates in period date, max date, 1 month. This measure calculates the total sales for the last month by using the dates in period function, allowing you to maintain granularity while focusing on a specific time period. 5. Best practices for managing granularity. 5.1. Use aggregations to optimize performance. Aggregating data at a lower level, for example, monthly or yearly totals, helps optimize performance, especially when working with large datasets. Pre-aggregate data in Power Query or at the data source to reduce the load on Power BI. 5.2. Use high granularity when necessary. Maintain high granularity when detailed insights are required, such as in transaction-level analysis. This allows you to drill into the data and perform detailed calculations or comparisons. Make sure to limit the use of high granularity data in visuals that don't need it, to avoid unnecessary performance overhead. 5.3. Combine different levels of granularity. Combine different levels of granularity in your data model to support both high-level summaries and detailed analysis. For example, use aggregated tables for high-level overviews and detailed tables for drill-through or deep dive reports. 5.4. Use hierarchies to manage granularity. Hierarchies in Power BI allow users to drill down through different levels of granularity, for example, year, quarter, month, day. Create hierarchies for time-based or categorical data to help manage multiple levels of granularity in reports. 6. Testing and validating granularity. Once you've implemented granularity, it's important to test and validate that your model provides the right level of detail for analysis. 6.1. Testing aggregations. Verify that the aggregated data matches expected results. For example, check that the yearly sales totals match the sum of the monthly totals. Use Performance Analyzer in Power BI to test whether your model performs well with the chosen granularity. 6.2. Testing detail level data. Ensure that detailed data, for example, transactions, is accessible and that drill downs and filters work as expected. Test that users can navigate from high-level views, for example, yearly sales, to detailed views, for example, transaction-level sales. Conclusion: implementing appropriate levels of granularity in Power BI is essential for balancing performance and analytical depth. Whether you need to aggregate data for high-level analysis or maintain detailed records for granular insights, understanding how to structure your data model to support multiple levels of granularity is key. By following the best practices outlined here, you can ensure your Power BI reports are optimized for both performance and insight, a critical skill for passing the PL300 certification exam and real-world Power BI development.